Whole fresh loofah enters under controlled receiving conditions to preserve traceability and reduce handling damage. Segregated staging keeps incoming lots organized before quality checks and prevents mix-ups between suppliers. Labels tie every crate to receiving records, so quality events and yields can be traced through the entire job.
Early visual inspection screens for bruising, decay, and contamination before the lot enters food contact equipment.
Surface damage can accelerate spoilage and increase trim loss, so defect grading starts before wash and prep. Representative sampling supports objective checks, rather relying on appearance alone.
Cutting a sample confirms internal condition and maturity before large volumes enter the line.
Incoming produce temperature.
Quantified grading keeps lot disposition consistent and avoids subjective receiving decisions.
Quarantine prevents doubtful material from reaching the line until quality staff decide whether to reject or trim it separately.
Formal release ensures only lots meeting quality criteria move into production under FIFO control.
FIFO handling limits residence time and helps keep incoming produce condition consistent across the run. Scanning crates at line entry preserves lot continuity from receiving through processing and packing. Metered feeding avoids surges that can compromise wash efficiency and manual inspection later. Transferred into the wash flume, beginning the cleaning process. The flume transports raw produce gently while loosening soil before more targeted cleaning. Gentle agitation improves soil removal without bruising the produce before inspection and trimming.
Ensures the wash chemistry performs as intended before final rinsing and inspection.
A final rinse removes residual sanitizer while keeping the raw produce on a controlled, hygienic path.
Improves downstream visibility for sorters and reduces unnecessary dilution in the process.
Surface drying improves camera visibility and manual defect detection without overheating the raw produce. A single-layer presentation is essential for reliable human inspection and later optical sorting. Proper presentation improves defect detection and prevents good material from being hidden in clusters.
Early removal of visibly damaged produce protects yield quality and reduces unnecessary load on later steps.
The technician briefly pauses each piece for a thorough recheck under the inspection light.
Label spacing is necessary for optical systems to classify defects accurately and consistently. Correct sort parameters prevent good product loss while maintaining a realistic defect standard for the run.
Automated rejection removes inconsistent raw material more uniformly than manual sorting alone.
Once defective pieces are removed, the accepted stream can move into preparation with better consistency.
Controlled presentation at trimming reduces unnecessary flesh loss and prepares the produce for uniform size reduction.
Removing the stem end eliminates tough tissue and improves the consistency of the puree feed.
A visible controlled split keeps the edible process stream separate from fibrous material destined for recovery.
Keeping the peeled flesh moving separately protects the main product route before size reduction. Controlled peel collection preserves a usable fibrous side stream without risking re-entry to the food product line.
Coarse cutting creates a more uniform feed for grinding and reduces load fluctuations downstream.
Even feed distribution helps the grinder work steadily and supports a consistent particle size. Controlled metering prevents overloads and keeps particle reduction predictable. Grinding converts the cut pieces into a pumpable mash suitable for pulp recovery and screening. Enclosed pumping reduces exposure and moves the mash hygienically toward pulp separation. Pulper begins separating usable soft tissue from larger fibrous fragments in a controlled enclosed system.
Pulp recovery improves mainline yield, while coarse fibrous residue is kept on the dedicated byproduct route.
Removes remaining coarse particles and prepares the product for downstream deaeration and heat treatment. Fine screening improves texture while keeping non-compliant coarse solids out of the main aseptic product stream before the puree enters balance storage. A balance tank smooths flow variations and keeps downstream equipment fed steadily without exposing the product.
Expulsions.
Deaeration removes trapped air that can affect oxidation, fill stability, and later thermal performance.
Removing entrained air helps maintain product color and reduces foaming downstream. After air removal, the puree moves in a closed sanitary route to standardization and thermal processing. The pressed fiber remains a separate recoverable side stream and is now ready for controlled drying. Even loading supports uniform drying and prevents wet pockets in the fiber byproduct. In-process sampling confirms whether the lot is already within specification before any adjustment is made.
pH verification supports process control and helps confirm the thermal step will run within validated conditions.
Standardization uses only the same product stream or concentration, keeping composition lawful and consistent. Gentle mixing distributes the adjustment evenly, without entraining new air into the puree. Controlled transfer maintains a steady feed into the texture conditioning step before heat treatment.
Homogenization evens out particle distribution and helps the puree fill more consistently downstream.
Controlled drying lowers moisture to a stable level for later milling and bagging of the fiber byproduct. Once dried sufficiently, the fiber can move to size reduction without risking clumping or unstable storage. Moisture confirmation prevents under-dried material from moving into milling and bagging. Standard milling turns dried fiber into a more uniform powder suitable for a stable secondary product. Milling creates the final powder form, while enclosed handling protects hygiene and worker visibility.
Sifting improves uniformity and removes oversized particles from the fiber byproduct.
Separate bagging completes the secondary fiber product without interfering with the aseptic puree line.
Wastewater treatment removes solids from non-product streams, and this material never returns to food production. Dissolved air flotation removes suspended waste from plant effluent and remains completely outside the product system.
Biological treatment reduces remaining organic load before discharge handling, and this treated stream is never routed back to production. Sludge from wastewater treatment is contained as waste only and remains fully segregated from all food and byproduct systems. Accurate flow measurement supports stable heat treatment and reliable process records at the critical control stage. The pasteurizer inlet must receive a steady feed so validated time and temperature conditions can be maintained.
Validated set points are essential because pasteurization is a critical control point for product safety.
Reaching the target outlet temperature is one part of proving the puree has entered validated thermal processing conditions. Residence time in the holding tube completes the validated thermal exposure needed for safe aseptic filling. The diversion valve protects the line by routing product forward only when critical heating conditions remain within validated limits.
Time and temperature records provide objective evidence that the critical thermal step stayed within validated limits.
Controlled cooling prepares the validated puree for sterile surge and filling without exposing it to the environment.
CIP verification confirms the clean circuit is ready for sanitary service and helps prevent residue carryover into product contact equipment.
Conductivity at rinse endpoint shows cleaning chemicals are cleared before the line is released for product contact. The aseptic surge tank buffers the validated product ahead of filling while maintaining a sterile boundary. Stable level and sterile headspace conditions help the filler run smoothly without compromising aseptic integrity. Secure, sterile connections are essential because any breach here could compromise the validated aseptic boundary.
Aseptic filling transfers the thermally treated puree into a sterile package without recontamination.
Accurate fill control protects shipment consistency and avoids stress on the package during handling. Secure liner sealing preserves sterility and prevents oxygen ingress or leakage during storage and transport. A clear coating ties each filled drum back to the exact lot, thermal records, and raw material history. Check weighing confirms the final net content after filling and sealing without reopening the aseptic package. Final vision checks catch package integrity or traceability issues before the product leaves the filling area. Finished package foreign body inspection is placed logically after sealing, when the product is enclosed in its final container. Short-controlled accumulation keeps the end of line moving without rough handling of the filled drums. Controlled palletizing protects package integrity and creates stable loads for storage and shipment.
Even drum spacing improves pallet stability and reduces movement during forklift transport and storage.
Correct positioning at the wrapper prevents uneven film tension and protects the load during handling. Stretch wrapping secures the drums as a single stable load for storage, forklift movement, and dispatch.
Finished pallets are staged by lot for shipment, so traceability and order control remain intact through dispatch.
Luffa puree leaves under full traceability, with the byproduct fiber already separated and waste streams kept permanently outside the food route.